we're going to continue talking about acid-base design pKa. And so we talked in the previous video about the definition of pKa, and we know this is negative log of Ka. And because of the definition of Ka, we know that large Ka, so greater than 1, that means this reaction is product favor. So if we have an acid, Ka is large, you're going to have a lot of dissociation. If Ka is smaller than 1, then it's reactant favor. And if it is about 1, we'll say it's an equilibrium, neither reactant favor or product favor. Now, big Ka is also means small pKa. So strong acids, and if we remember these equation, HA plus H2O, and here for now we're writing the equilibrium. We don't know about the pKa's value yet. So conjugate base, conjugate acid, hydronium. So as it is, if the acid is strong, then Ka is going to be a lot of dissociation, is going to be product favor. That means Ka is going to be product favor, Ka greater than 1. But that also means by our definition that the pKa is going to be small. And conversely, if the acid is weak, that will be, say, strong acid. Now I'm going to write another acid and say that this time I have, now this equilibrium, we're going to say is reactant favor. Because of that, my Ka is smaller than 1. And I'm going to draw the arrow. It is reactant favor according to our definition of Ka. Again, because the Ka is smaller than 1, is small, that will represent a larger, say, we'll say larger. That's all relative. We're going to go to the scale in a minute. So the small values of pKa are associated then with strong acid. And larger values of pKa are associated with weak acid. And I'm going to give you a few examples of that. Let me see, what can I erase? I'm going to go here about the concept. For example, if we have sulfuric acid, we know this is a very strong acid. pKa here is -9. This is negative number. So this will be, say, the equilibrium here is like 10 to the 9, so very big. So product favor, a lot of hydronium, completely dissociated. If we consider, say, hydrochloric acid, pKa here is -7. It's still a negative number. So 10 to, in the order of 10 to the 7 would be the constant for this equilibrium. Again, completely very small here, completely product favor. So these two acids are very strong and are completely dissociated into hydronium and the conjugate base, corresponding conjugate base. And now let's talk about another acid that you're familiar with in your previous courses. This is acetic acid. Now the pKa of acetic acid is about 4.7. That's a positive number we see here. That is much larger in pKa value than this two. If we run this about 5, that means that because of this definition, the Ka here is in the order of 10 to the -5. That is a very small number. So that is, in other words, reactant favor, what we say. A larger number here, so it's larger number of pKa is associated with a number here that is much smaller than 1. Here it is for acetic acid. So larger pKa, much smaller Ka. So in this case, if this was acetic acid, it is reactant favor. What that says is, if you write acetic acid, and we have that in water, we're going to produce acetate, but now I'm going to draw the arrow in the reverse direction bigger because I know this is a reactant favor. And this is going to produce acetate plus, I need to write it down here, hydrogen. So now we can also use this, and we're going to predict now how do we use pKa values to predict where the equilibrium, furthermore in other examples, interacting acids and bases.